We're talking about degrees from the initial side, and we're having fun. Oh yeah, we're having fun. Oh yeah. All right. Today's gonna get real wild. We are gonna generate any angle. It might even be over 360 degrees, and you're like, Mr. Plant, when I see you do a 360, you do a full circle and then a dunk. How would we draw an angle bigger than that? I'm so glad you asked. All right, so we're going to be doing this on the graph, coordinate plane, but we're not really doing like X and Y coordinates. Now, if you were to divide a 360 degree circle into 4 chunks, 360 divided by 4 is 90. So each of these would be 90 degrees. So here would be like 0 degrees. Up here is actually positive 90 degrees. So it's weird because you start at like the flat side and you rotate up like that. So down here would be 180, down here would be 270, and then back at 0, one full circle would be 360. And then it could keep going beyond that, but we'll get there. So if we were to draw a positive angle, it always starts at 0 degrees. And then let's say we wanted something that was 100 degrees. That would be just a little bit past 90. Whoop. So that's how we represent 100 degrees. And that side where it ends is called the terminal side. All right, now let's also show a negative angle here. It's still going to start at 0, same spot, but negative angles dip down first. So here would be negative 90 degrees, and then negative 180 degrees, and then negative 270, and one full rotation this direction would be negative 360 degrees. So if we wanted something that was negative 250 degrees, it would start at 0, and it would wrap all the way past 180, but it wouldn't quite get to 270. So this could be negative 250 degrees. Now, we're not going to be taking out protractors and measuring that out, but you just have to make sure that it's showing up between negative 180 and negative 270, right? That's where negative 250 would fall, and obviously it's a little closer to 270, but again, we're not taking protractors to these angles, so do your best. There we go. Example 1, draw an angle with the given measure in standard position. Okay, all right. So I'm going to draw these graphs here, and we'll label the angles based on if we're doing positives or negatives. So 320 degrees, it's positive, so we'll say this is 0, here's 90, 180, 270, and I'll go ahead and throw the 360 right under that 0 as well. So if we're drawing 320 degrees, it always starts at 0 degrees. It's going to rotate past 270, but it's not going to make it to 360. In fact, how far apart is 320 from 360? 40 degrees. And half of this would be 45, so it's going to go just about there. So it's going to swoop all the way around and end right there. That's a 320 degree angle right there. Fun! All right, now we're going to do a negative angle. So again, 0 is always the starting angle over here, but it's negative, so it's going to dip down first. So down here we would say is negative 90 degrees. Here would be negative 180. Now, if you wanted, it's going to fall in that range, so you don't even need to label more, but come on, we're cool. We can make this negative 270, and one full rotation in this direction would be negative 360. This one's going to start at 0, and we're going to negative 100. That's going to be just beyond negative 90. Cool. And then this last one, it's a positive angle, 990. Whoa, that's pretty huge. So here would be 90, 180, 270, and this was 0. It's also now 360, but we need more. We could keep going if you want. If we keep adding 90, here would be 360 plus 90 is 450, then 540, 630. We're still going. We got to get up to 990 degrees. So let's see, we keep adding. Here's 720. Whew, 810. 900 degrees. And 990, finally. So we're going to have to show that it's gone around the circle more than once. Actually, it's going around more than twice. So here's how we do that. To represent one full circle, you just do this. That's 360 degrees. We have to do that again. So we're going to make another spiral. That shows that it went around twice, which would be at 720. Now we're up at 810, 900, and 990. So it ends right here. Those angles that end right on one of those quadrants, it's called a quadrantal angle. So that is 990 degrees. Whew, that's a doozy. Now if you want in the future, you don't have to label all these other ones, but you would want like the 720, 810, 900, 990, and we'll get to what these angles are called anyway. They're called coterminal angles. Coterminal angles are angles in standard position that end at the same place 360 degrees apart. For example, draw a 510 degree angle. You got it. All right. So it's a positive angle. So we have 0, 90, 180, 270. Here would be 360, and 450. And then 540 would be here. So if we were drawing a 510 degree angle, that would be one full rotation, and then a little bit past 450, not quite to 540, so it might be somewhere like here. 510, 60 degrees, yeah, all right. So here's a 510 degree angle. Now, if we were to draw a 150 degree angle from the start, it's the same ending place. They have the same terminating side angle. So those are called coterminal angles. The way to find coterminal angles is you could just keep adding a rotation or subtracting rotations from it. Now, today we're talking about degrees. A full rotation in degrees is 360. So you could keep adding 360 or subtracting 360 from the angle to find a coterminal angle. And there are infinite coterminal angles because you could just keep adding 360 or keep subtracting 360. So if we're doing, this says to give us a positive and negative coterminal angle. So we could just take the angle and add 360 degrees to it. Boom, we have a positive coterminal angle. So this will give you 425 degrees. There you go, there's a positive coterminal angle. Is that the only one? Absolutely not. You could keep adding 360, add 360, add 360, on and on. Now we do need a negative one as well, so we're going to subtract a full rotation, minus 360. And if you did 65 minus 360, that's going to be negative 295 degrees. Is that the only coterminal angle that's negative? No, you could keep subtracting 360, huh? So 410, you could add 360 to that. And that would give you 770 degrees. There is a positive coterminal angle. Now, if we subtract 360 degrees from it, we're at 50 degrees. That's also a positive coterminal angle. So that could be included in the positive answer. However, we still do need a negative. So we have to subtract a whole nother rotation on that, which will give us negative 310 degrees. And you could keep subtracting 360. You'll get sick of hearing me say that. Oh, Mr. Plant, we can never get sick of you. Oh, thank you. All right, negative 60. Let's add a rotation to it. Let's add 360 degrees. Negative 60 plus 360 is positive 300 degrees. Sick. We have a positive coterminal angle. We're going to need a negative one. So let's subtract a rotation on that. Negative 420 degrees. That was delightful. Oh, so much fun, those coterminal angles. Oh my gosh. And then I believe this is the last thing we have to cover, reference angles. Let's draw the angle first, and then we'll talk reference angle. So let's draw all three of these angles. So 135, it's a positive angle, so 0, 90, 180, 270. We'll come back to that. Here we have negative angles that we're using, so 0, negative 90, negative 180, negative 270, okay. And then this one is also positive, 0, 90, 180, 270. I see it's going to go beyond 270, so I'm going to put 360 under that 0 just for my own reference here. So if I'm drawing this first angle, 135 degrees would show up here, between 90 and 180. So a reference angle is an angle that starts at the terminating side. It starts where your angle ends, and it forms an acute angle with the x-axis. The x-axis is the flat one. Acute angles are less than 90 degrees. So here's one side of the angle. The other side, to make an acute angle with the x-axis, would be right here. So we're trying to figure out what's the measure of this angle right here. Use your brain a little bit. You guys are wicked smart. Look at this. This whole angle would be 180. This part of it is 135. So if we needed this missing part, we could just do 180 minus 135, which leaves us with a 45-degree reference angle. What? That's pretty fun, right? Now, it always has to be positive, and it always has to be acute, less than 90 degrees. So check this out. We're doing negative 105. Starts at 0. Negative 105 would be just past this negative 90. The reference angle would start where that ends, and it forms an acute angle with the x-axis. Look, these two angles always add up to 180. Now, that one's negative, but it doesn't really matter. We could think of it as positive, right? If this is 105 degrees, the whole thing's 180. We could just do 180 minus that 105. That gives us 75 degrees for that reference angle. Unbelievable. Unbelievable. These reference angles come really in handy once we get to the unit circle. All right, 325 degrees. That's almost a full rotation. So it starts at 0, it goes past 270, and let's call this 325. So the reference angle starts where that one ends, and it forms an acute angle with the x-axis. Now look, one full rotation is 360 degrees. We've already gone 325 of it, so we just need to know what's missing here. Easiest way for me to do that is to just do 360 degrees, the full circle, minus the 325 that we've already gone. So that leaves us with 35 degrees. So let me draw something here for you guys that you can kind of reference back to. Zero or 360. So this top right zone is called quadrant 1. The top left zone is called quadrant 2. Down here is called quadrant 3. And this last one is quadrant 4. So I'm going to give you some quick equations where when your angle ends in that quadrant, it'll tell you the reference angle. The nice thing is, let's call our angle theta. if your angle terminates in quadrant 1, your angle is your reference angle. So the reference angle here is just theta. Cool. If it ends in quadrant 2, it's going to be between 90 and 180. So the way you find the reference angle in quadrant 2 is you just do 180 degrees minus your angle, minus theta. Now here in quadrant 3, none of ours ended in quadrant 3 except for the -1, but most of ours are going to be positive. You're seeing how far beyond 180 that you went. So what we can do in quadrant 3 is we can take our angle, our theta, and subtract 180 degrees, and it'll give us our reference angle. And the last quadrant is like, how close is it to 360? So in this quadrant, you could do 360 degrees minus your theta. That'll be our reference angle. So that could be like, if you were to do an index card for this test, I don't think you're going to be able to, but if you could, that would be something nice to jot on there. It's like a nice quick reference, but if you have it in your notes too, that'll help you with the assignments. I think we're done. Yeah, dude. We're all done with degrees, man.